Hi girls, I hope you're having a nice holiday. I just thought I'd make you another video, this time on the factor theorem. And what I've done there is I've written down the statement of the factor theorem, which says if p a over b equals 0, which is another way of saying if the fraction a divided by b is a root of the polynomial, or is a factor of the polynomial. Oh no, that's not true to say it's a factor. What it means is that if this is a factor, bx minus a, I'll write that again because that looks atrocious. So if this is a factor, or if that divides px, where b and a are both integers but they don't need to be positive, then it means that a, the number on top of the fraction, divides the constant term, and it means that b, the number on the bottom of the fraction, divides the term at the front. And let's put this into practice with a polynomial that we're quite familiar with. Let's just pick, for the sake of argument, a quadratic. I'll just pick that one for the sake of picking something. So what it means is that I can write a list now of every single possible rational factor. This doesn't include irrational factors, and so these are only the factors where it's one number divided by another, where those two numbers are whole numbers. So it means that the possible factors are, firstly, the whole numbers, and the whole numbers must divide 1. So the whole numbers are 1 and minus 1. So that's the only whole number roots. And then the other roots are those same whole number roots divided by all the divisors, all the divisors of, all the divisors of 3, which is only 3. So those are all of the possible roots. And then what we will do is we'll say, alright, we essentially that we have done the guessing part of guessing and checking, and then we do the checking part of guessing and checking. So we would just go, right, what is P1? Well, P1 is 3 minus 2 minus 1, which is 0. So that is one of the roots. And then we would use polynomial division, which was in the last video, to find the second root and the third root and so on and so on. But essentially, when it comes to quadratics, we know how to do this already, right? We've got the Mann method, we've got the quadratic formula, you've got other things that you might be useful, like the difference of two squares and things like that. But we know ways to do this already for quadratics. The point is, when we get to cubics and things, the only really efficient way, there is a formula but it's ridiculous, the only efficient way really is to guess and check the first root and then do polynomial division. And if you're doing a quartic, you have to guess and check 2 roots and then do polynomial division. Okay, so let's put this into practice now. Let's start with a polynomial, and let's start with the polynomial px is x cubed minus x squared minus x minus 2. And let's factor this polynomial fully using the factor theorem. So first thing we know is we know all the possible roots, all the possible rational roots. It would be ridiculous to try and check irrational roots. It's just a loser's game, that one. So first of all, plus 1 minus 1 are always possibilities, right? Because 1 divides every number. And just remember, whenever you're doing this, whatever roots you write down, always write down the negative ones. Always. So at the moment I'll just think about whole number roots. So the whole number roots have to divide 2, ignore the minus sign. So they have to divide 2, so the only other option is plus or minus 2. And then we look at the leading coefficient, the coefficient for x cubed, which is 1. Nothing divides 1 except 1. So in fact we've already written down all of the possible rational roots. So now it becomes a matter of checking. And pick your favourite. My favourite is the number 1, because it's the easiest always. Second only to 0, but 0 is never a root. So, well, 0 is sometimes a root, but it's really obvious when it is, and hopefully it's obvious why that's true. So I get 1 minus 1 minus 1 minus 2. And I check that. So what's that? 1 minus 1 is 0, minus 1, so that's minus 3. Okay, so not a root. you'll start to develop an instinct now as to whether or not it is necessary to even check -1. And I think in this circumstance it is, but the thing you need to think about there, and I'm just kind of putting ideas in your head, is that the only thing that's going to change when I sub in -1 are the odd powers. That's not a very good highlighter for this example, but they're the odd powers, and they're just going to switch from positive to negative. And you look at the way they're going now, at the moment they're positive and negative, and they're both going to switch to be -1 and +1 there, so nothing in fact is going to change, and it's -3. Now, that's not the ideal circumstance for this argument, but it's just good to think about it all the time. Let's check 2 next. So P2, get used to 2 cubed being 8 if you're not already. Ooh, it's almost as though I thought of this polynomial beforehand. So P2 is a root. So what that means is it means that I can write Px as, so x minus 2 is a factor, and what's left is a quadratic. And I could do polynomial division, and you should be practicing doing polynomial division. I'd encourage you to do both in this circumstance. I could do polynomial division, but I'm going to do my cheat way, which is to say, well, it's x cubed, so it needs to be x squared. The constant is -2, so it needs to be +1. And then I'll just put in plus ax. I'm going to try that one again. I'm going to hopefully get a stylus for Christmas, maybe Santa will bring me one. So then I try expanding. Now let's do this in a different color because I can rub it out then. So I get Px equals, let's pick a darker grey. So I get x cubed minus 2x squared plus ax squared. And that's all the x squared terms. Whoops. And all that's left is x's and constants, which don't really matter because all I can do is I'm going to say, well, that must be the same as the minus x squared. So therefore, a must be 1. Okay, so I'm just going to rub that out. You should leave that in your working, obviously, but I'm not doing an exam right now, so I'm fine. So Px equals x minus 2 times x squared plus x plus 1. So far, if we were trying to sketch this polynomial, which is often the end goal, what it means is it means that there's a root at 2. We don't know if it's a single root or a double root or even a triple root. So it could be a pass-through, it could be a bounce, and it could be an inflection. It's pretty obvious that it's not an inflection, I think. It's not necessarily super obvious that it's not a bounce, though. And now, the next step is to attempt to factorize this, well, to actually factorize it, because we can always solve quadratics, and then sketch. There are other things I could do. For example, I could get out my calculator and I could evaluate, I don't know, P 2.01, P 1.99, sorry, and I could see where the polynomial is here and here, and I could use that to determine, you know, does it look like that, does it look like this. So those are things I could do, but aren't really at all necessary in this circumstance, so I'm not going to do them. Instead, I attempt to solve the quadratic that I've got. And if you look at it, it's man method with 1 and 1. Two numbers that multiply together to give 1, add together to give 1 are not whole numbers. So I try quadratic, and in particular, if I just look at the discriminant, I get 1 squared minus 4 times 1 times 1, which is minus 3, so there's no roots. So that means that the quadratic is factorized fully. What I encourage you to do now is pause the video for a second and attempt to draw the curve for yourself. Okay, so hopefully you've tried that. What I'd encourage you to do now is to go on Desmos and enter it and see how your graph is. To be honest with you, I haven't actually done this yet, but I know, for example, it is a cubic that is positive and only has one root, so it has to do something like this. But my problem is that I don't know where the turning point is, and neither do you. And in fact, I've drawn a turning point there. It's almost certainly not a turning point there. So it might be like that. It might be like that. Might not have a turning point like that one did. It might have a pronounced turning point as long as it doesn't go through the axis again. But there's quite a lot of different things that could happen. Okay. So I hope you're having a relaxing holiday. Here's a photo of the garden bed that I built, finished yesterday. My shoulders and back are a bit sore after shoveling 2 tons of soil, but that's okay. What else has been going on? Oh, there's a new song by Sia. I hope you've all listened to that. Ready for critique next Tuesday. I will post a video on probably Friday, maybe Thursday, that will lead into Tuesday's lessons. It'll be on stuff we basically already know, and we're just pushing it a little bit further as always. For those of you doing Extension 2, I'm going to post a video for that as well before Tuesday, just to lead into the first lesson of that. If you could do me a favour and pass that on to the girls not in my class who won't be seeing these, that would be fantastic. Alright girls, enjoy the rest of your break, and I look forward to seeing you all on Tuesday.